Hi there, folks. We're going to continue our set of videos in factoring by grouping. In our previous video, we have finished the examples from numbers 1 to 3. We're going to continue with the examples number 4 to 7 for this middle video. Okay, so for number 4, what we're going to do is we're going to factor 9cx plus 27cy plus 11x. Oops, sorry, let me write that correctly. 11x minus 88z plus 33y minus 72cz. Okay, so this is quite a mouthful. We have three terms in this expression. So what we're going to do is to factor them. What we will do here is we're going to observe the common things that is transpiring in this six-term expression. Notice that in the first term, there is an existence of a c variable or constant. Let's call it variable for now. Okay, c constant. We have a c variable rather, and a c variable here. So what we're going to do is to group all the terms with the c's, and it will turn out to be 9cx plus 27cy minus 72cz. Okay, and since if you're going to notice all the remaining numbers have mixed operations, let's just put a plus sign outside and then we're going to copy everything. So we have 11x, everything that is left, minus 88z plus 33y. Or how about this? Let's write that in proper order, x, y, z. So let's put plus 33y minus 88z. And then let's have the common monomial factor for each of these terms here. So on the first grouping, I think the common factor is 9c. This is divisible by 9. This is actually 3 times 9. And this is also divisible by 9. This is 8 times 9. Okay, so all of them have a 9c in these terms. And here, all of them are divisible by 11. This is 3 times 11. Let's make use of the rate start. And this is 11 times 8. So the common factor for the second grouping is 11. So let's take them out, shall we? So we have for the first grouping here, I'm going to write it in red. We have 9c. What is left is x plus, we have 3y since 9 is taken out. So we have a 3, which is a coefficient which is left, and then y is left. And then we have here 8z. Okay, that's for the first grouping, and then let's continue. Let's do that for the second grouping. That I'm going to write that in red. We have plus 11. 11 is the common monomial factor there. And then we're going to write all the terms which are left. So 11x, we're going to take the x out of it. We have 33y. We're going to take the 11 out of it, but we retain the 3 since we cannot take it out. 3y. And then for the last term, we have 88z. So we're going to take out the 11, written here. And then we're going to write the 8 as it is, 8z. And hopefully you can see now the common grouping. You have x plus y, 3y minus 8z, x plus 3y minus 8z. So since we have that in common, I'm going to write it in yellow, rather in green. Okay. So we have x plus 3y minus 8z. Okay, and then we're going to write what is left. We're going to use red because we have used red for this. So we have 9c plus 11. Okay, so this is our answer for number 4. Quantity x plus 3y minus 8z times the quantity of 9c plus 11. So again, by commutativity, it's okay to write the 9c plus 11 on the first side, on the left side. So for number 5, okay, that's our number 4 example. You can always rewatch that if you want. Number 5, let's have x cubed plus x squared minus 4x minus 4. So let's get the common factors for each of these terms. Maybe it's better to group them so that we can see the groupings. X cubed plus x squared. We're going to get the minus signs because it's common to both terms, both third and fourth term. So minus 4x. And then since we have taken out the minus sign, this will become plus 4. Now, by common monomial factoring, we can see that there are common factor in this part. Again, remember that x cubed is actually a group of factors of 3x's in x, and x squared is a group of 2x's. So what we're going to do is to take out this 2x's here. And then here, what is common here is the 4 and the 4 for this side. So let's get the common factors out. Don't forget x times x is x squared. Okay, so that will be our factor outside. So we have x squared times the quantity of whatever is left. So we have, if we're going to get x squared from x cubed, we still have the x, which is left. And then if we're going to get the x squared from x squared, that's going to be only 1. Okay, and then we're going to copy this minus sign and then factor out the 4, write the 4 as a red pen, and then copy the rest, whatever is left. 4x, take away the 4, or we're going to divide the 4, so we've got 1x, and then 4 taken out is just plus 1. And hopefully you can see again our common factors, our common grouping, factoring by grouping then. So we have x plus 1. So we're going to write here x plus 1 times the quantity of x squared minus 4. X squared minus 4. And this can be the answer. Okay. Now, what we do here, actually, if you really want to very simplify it, if you have noticed this second grouping, this can be, we can apply the difference of two squares here. So if there comes a case that if you really want to simplify it completely, this is the most simplified version. This is just equal to, so we're going to write x plus 1. So fact, the difference of two squares, can you remember that? So if we have, make use of a black pen here. If we have x squared minus y squared, it's equal to saying the first grouping plus x, and then the second grouping x minus y. And if you do that here, if we're going to apply that, what we have is x, square root of x squared is x, square root of 4 is 2, x plus 2, x minus 2. And this is our answer for number 5. X plus 1 times the quantity of x plus 2 times the quantity of x minus 2. Again, if you want, you can, by commutativity, they can be written in any form without altering the answer. Okay, so that's it for number 5. For number 6, what is it for number 6? So say we have x squared minus 2x plus 1 minus y squared. Okay, this is kind of weird because we have a y and there's no other factors with a y on it. But maybe we can do this. Let's try this one. This is actually a perfect square trinomial. Remember our perfect square trinomial. This is a perfect square. This is a perfect square. Multiply this perfect square and then times multiply them by 2. So we have this as our middle term. So since we will be applying the perfect square trinomials, how can we write them? Again, so this can be written as x minus 1. Let me fix that. X minus 1 quantity squared. How did that happen, sir? So throwback, just a remark or recall rather. So we call this our perfect square trinomials. And how do we do that? So if we have, say, a plus b quantity squared, it's equal to a squared plus 2ab plus b squared. If it is minus sign in between, a minus b squared, so we have a squared minus 2ab plus b squared. So since we see that there's a minus sign here, it should be a minus sign over here because it corresponds to the minus sign there. Okay, so that's for our first expansion, or rather first simplification of our long term here for four-term expression minus y squared. We're just going to write that because we cannot do anything about that for now. And then, as you can see, again, we can apply something here, number 6 in this line. What can we apply, sir? Again, recall our difference of two squares. So we have recalling a lot. Difference of, sorry, two square thoughts. So if we have again a squared minus b squared, it's just equal to a plus b times the quantity of a minus b. Yeah, so let's apply it here. So since this is a perfect square, this is also a perfect square. They are both squared rather, and then there's a minus sign in between. So what can we do? We can rewrite this in this form. So maybe we can make use of another you know grouping. So we have x minus y. Just remember this is a term. Okay, this is a single. We are looking at it as a single a. So this is like a squared minus b squared. So we're going to alter the signs here. So x minus 1 plus y. And the other one is x, or sorry, this should be 1, not y. Let's make this 1, shall we? Okay, erase. There you go. Let's make this 1, x minus 1. Then we have x minus 1 also, but this time it's minus y. Okay, there you go. So that's our partial answer for number 6. What we will do then is we're going to take out the x minus 1 from both of them. Okay, as you can see, both of them have the x minus 1, okay, as a factor. Okay, so, or we can just first simplify. Maybe we can get rid of the brackets. We cannot, sorry, we cannot do that because this is not a factor. This is a separate term, so they're in one expression. So maybe what we can do in this number 6 is just, delete the groupings inside the bracket. So we have x minus y if you really want to make it formal, minus 1. And then what the other one is saying is that x minus y, or rather this is plus, I'm sorry, minus 1. Yeah, and this is our answer for number 6. Okay, this is our answer for number 6. Quite not that we expected, since we have applied perfect square trinomials and difference of two squares here, right? So let's proceed to number 7 now. This is our last digit here, or last number. Okay, for number 7. So number 7 is showing us y cubed minus 2y squared plus 5y minus 10. So what we're going to do is to group this. Maybe we can group this y cubed minus 2y squared. Let's group this as one grouping. And then since they don't have the same signs, let's just put plus outside, and then let's write 5y minus 10. Yeah, so we simply put them in a grouping. And the four terms are now becoming two groups. And then we will be taking out the factors. So y cubed is actually like y times y times y. Y squared is like y times y. So they both have the y's. So let's take the y squared out. So remember, y times y is y squared. So what we have is y squared times whatever is left. So what we have is, if we're going to take y squared from y cubed, we still have the y. If we're going to get the y squared here, we still have the minus 2. Okay, that's it. Now, how about for the other term? So both of them have a common factor of 5, actually, since 5 is 5 times 1 and 10 is 5 times 2. So if we're going to do that, um, we're going to take out the common factor, which is plus 5. And then what is left with this term is y minus 2, since 10 divided by 5 is 2. Okay, so, and then, wow, here we go. Both of them have a common factor grouping, which is y minus 2. So what are we going to do? We're going to take that out, that y minus 2 there. Okay, and then put that in front, put that up front. So maybe we can write y minus 2, okay, times the quantity of y squared plus 5. Again, y minus 2 times the quantity of y squared plus 5. Okay, there you go. So this is our answer for number 7, the last number in this video. Okay, if you want, here's the question, here's the solution. Okay, so thank you very much for watching. I hope you learned something from this video. And yeah, don't forget to hit like and subscribe. I will be posting the last video after this. So thank you very much.